Lecture number 21, Hydraulic Structure Part 3. Next section is the safety criteria to check the gravity dam. The first criteria we call the sliding resistance is equal to summation of force, horizontal force, summation of vertical force, less than F or the coefficient of the friction, about 0.75. This coefficient is come from what you learned from the statics. Assume that this is a block, that there is a force acting on this block, and in the static condition, then we can write the force, the free body that came up of this block for the weight of the blocks and the reaction at the bottom, and the external force and the friction force. Based on the equilibrium equation, capital F is equal to F and N is equal to mg. And friction force is equal to mu n. Mu is the coefficient of friction, and mu is equal to F divided by mg. In this case, F is the mu from the static, okay, and we can write that mu is the summation of the horizontal force divided by vertical force. So that's where is this equation come from. And in case of the abnormal load, the required friction factor is less than 0.75. And the next safety criteria we call the shear friction factor is come from the friction, skill friction plus the shear resistance divided by summation of the horizontal force. Okay. And for shear friction factor, its term S is shear strength of the material at the bottom foundation of the gravity dam. For example, it's about 140 for poor rock and about 500 tons per square meter for good rock. And I is about safety factor is 0.5 in area. And safety factor should be greater than 5 for normal loading and 4 for abnormal loading. Okay. The next topic is the stress. The stress, I think you learned stress of material from mechanical material. In this case, there's two equations. The first is we call the sigma z is the vertical stress at the toe or the heel of the dam. In this case, toe is, we already explained in the previous lecture. And the P is the total vertical load, and T is the width of the dam, and E is eccentric distance. So D is the eccentric distance between the location of the resultant force acting on the location of the centroid of the object. Okay. And the next equation is for the principal stress. Okay. It's is a function of the vertical stress, and PD is the summation of the normal stress due to water and earthquake. And for the downstream, principal stress is equal to this term, and for upstream, principal stress is equal to this term. In case of the upstream phase, vertical perpendicular to the floor, so phi u is 0. So phi u is mean the angle between the vertical and the surface. Okay. In case of the phi u is 0, we got this term pu reduced to this term because of sec 0 is 1 and tan 0 is 0. And for the p, in case of the no water downstream, PD is 0. So principal stress is equal to vertical stress times 1 plus the tan PD square. Okay. So we can write in terms of combination between the principal stress and shear stress like this for the relationship on the vector force.